Hey, g'day everyone, HCOP here again. Just in reference to the video I did last year on Jupiter and Mars and its correlation that it had with Earth's Quasi Biennial Oscillation. Oops, sorry, I just inadvertently clicked that. I've since been able to further refine this, or should I say, make it even simpler. Back then, I downloaded, as you can see here, the data for Jupiter, data for Mars, the X and Y coordinates in reference to the Sun. And we did that via the NASA website. So back then, the Sun was a reference and we got the X, Y coordinates. So that's pretty straightforward, the X and Y coordinates. However, what I've done this time, instead of using the Sun as a reference, I've actually used Jupiter as a reference, and I'm downloading the Mars data in reference to Jupiter with the XY coordinates. Now, what NASA are able to do with that, there's a particular table there they give you where they give you the distance between Mars and Jupiter. So what we're getting is we're going to get 120 years of data of the distance from Jupiter to Mars, Jupiter to Mars, Jupiter to Mars, and so on, Jupiter to Mars. And that's the range, and on their columns they call it the RG column, which we will get to in a second. So I did that, last year. If you go back look at the other video, you'll see here, this is a table I used, and the coordinate origin was the Sun. This time we're going to now change that, and we're going to make it Jupiter, which I've just clicked. Okay, so Jupiter, do a search. Oh, I don't like that. Let's try it again. Let's try at Jupiter. At Jupiter. Here we go. Okay, so we're getting the Jupiter body center down here. Click, and we're selecting. There we go. Okay, so the time frame is from January 1900 to December 2019. So let's generate the data. So click, and here's all our data here. Now, I've actually already downloaded it, but there's nothing stopping you guys trying it, and probably you need to anyway for all openness. It's just to verify what I've done. And what we're now doing, so I've already downloaded that, but what you're going to see here, which I've copied, and you'll see again on the other page, is we're going to be using the RG data, and that is the range, which is the distance from the coordinate center, and the coordinate center is Jupiter. So it's going to give us in the RG column Mars to Jupiter RG, or distance should I say. So let's back up the top. Okay. Oh, hang on. So the QBO. Where did I get the QBO data from? Back to the internet. Okay. On the KNMI Explorer. It's a Dutch website. They have a lot of data in there. So Quasi Biennial Oscillation right here. We're going to the reconstructed data by Stefan Bommelin, and we're using a 10 HPA. There it is there. And we don't want all that data. We're just going to select. There you go. So I've hit select. It'll give it to us in a second. Okay, there's the QBO. And we're just going to download that data, raw data. Now, let's do it again. Okay, so Control C or copy. Go back to the Excel spreadsheet. We'll go QBO. Look, you can see I've actually already downloaded it. Let's just paste it, and you'll see that will match up. Well, 8.6. It's just rounded up. I'll go home and there we go. 857, 857. Yep, that's all fine. So that's the data I've used, the QBO data. The Mars data I've already put in. Now the parameters, we've done that there. Okay, the test sheet. RG. That's the distance from Mars to Jupiter, and that's what we're going to be using. So there's an extra column I've introduced here, and it is a 12-month average of the RG column. So we're just smoothing the data. Okay, and I'll just double click that. So if you're familiar with Excel, you know I've just made that formula carry through. The reason why I've done a 12-month average is because I've had to smooth out the QBO data over here, and you'll see why in a sec. Okay, at the moment it's on the 12-month average, but if I take it back to the monthly data, you can see it's a little bit jagged. It's a bit spiky over here. So what I did was I just created an average 12 months. So if I'm going to average the QBO, let's average the range. And again, you'll see here 12-month average from A22 down to A33. Okay, let's just transfer the same formula all the way down, which I've done. And this is what we've got. This is the result. The distance from Mars to Jupiter mimics Earth's quasi biennial oscillation. And it does add up to around 65. It then goes out of phase. So if you're looking from here up until about 88, 89, this area here, it goes out of phase. And then it falls back in phase. I can't tell you why. I'd love to know why. This is the part I've been trying to find out. Why does it go out of phase? And at this stage, I've not been able to nail it. But what I do have to say is the correlation between the distance of Mars to Jupiter, pretty well nailing Earth's quasi biennial oscillation, needs to be investigated. The fact that a Russian scientist over here in Alexy Retejum had identified there's something going on with Jupiter and Mars. He actually even went on to say that Venus was involved, but I haven't been able to fit in Venus, how that happens. The fact that this Russian scientist has got involved and told us there's something going on, there's something there. I just can't nail it. I'm hoping someone else can. So that's how simple it is. The distance, RG. I need help here, guys. Someone help. Okay, have a good day. Cheerio.